In this lesson, we're going to be solving systems of equations using elimination and substitution. So this should be a review from Algebra 1, assuming you took Algebra 1. And if not, if you don't remember how to do it, then this will be a good refresher, but you should go look up some more resources if, like, you don't remember it at all. So I'm going to start with this system, and when you're solving systems, you want to try to eliminate one variable. And the way that you want to eliminate it is by having opposites. So for example, this is a 5x. If this were a negative 5x, then I could add these two opposites together and get 0 x's, right? 0x. I don't have that situation. I don't have it over here either, but I can create it. So for this negative 3 and this positive 2, I could turn these into a negative 6 and a positive 6. Because if I had those opposites, then I could add them together and cancel out one of my variables. In order to get this term to be a negative 6, what would I have to multiply by? I am hoping that you said 2. That's right. Negative 3 times 2 will give me a negative 6y in that spot. What about the other one? What would I have to multiply by this 2y in order to make it a 6y? Right, 3. So that's what I'm going to do. I'm going to multiply each of my equations, but I can't just multiply that one term. I have to multiply the entire equation. So that means my new system is going to be, I'm going to multiply everything here by 2. 10x minus 6y equals negative 2. Now for the second equation, I'm going to multiply everything here by 3. 9x plus 6y equals 21. Now that I've got opposites for my y term coefficients, I can add these equations together because I know that these will cancel out or give me 0. My x's, when I add them, I get 19x. And my constant terms, when I add them, I get 19. And now there's one step to solving this simple one-step equation, and we get x equals 1. Now you might think that we're done. We got a solution, right? But we're solving systems here, which means that we've got 2 lines. So let's say one of them goes like this, and maybe the other one goes like this. And when we solve the system, we're finding where they intersect. And every point on the coordinate grid needs 2 values to represent it. We need an x-coordinate and a y-coordinate. So we found the x-coordinate. Now, guess what we need to do? Find the y-coordinate. So we're going to pick the easier of the 2. I think that this equation looks a little bit easier than this one just because it has less negatives. So let's use this equation, and we're going to plug in the x that we found. So instead of 3 times x, I'm going to write 3 times 1, because that's what I found down here, plus 2y equals 7. And I'm going to solve this equation, simplify, you know, inverse operations. Oh, the joy of solving equations. Last step, and I get y equals 2. So now that I have my x-coordinate and my y-coordinate, I can write the intersection point. And that's it. And you could take these values, 1 and 2, and plug them in here, 1 and 2, and plug them in here, 1 and 2. And when you plug them in, as a way to check, you will get true statements. So this will equal negative 1, and this will equal 7. Because the intersection point is on both lines, so it's a point that makes both equations true. All right, let's try another one. Now that method that we just used is called elimination because we eliminated one of the variables. For this system, I'm going to use substitution. And if you're asking, well, why? Why wouldn't you just use elimination? You could. You could use elimination. I'm just going to use substitution because I wanted to refresh you on both of the methods so that you know what your options are. So with substitution, what you want to look for is a variable that's by itself, because you want to isolate that variable, get it all by itself on its own side. So it looks like this would be the easiest variable to get alone, right? This would be a little bit harder just because it'd be more steps. But this one I could get alone fairly easily. So that's what I'm going to do. I'm going to take that first equation and I'm going to solve for x. So that means this has to move over to the other side. And then I still don't have x by itself because it's got a -1 out in front. So I have to divide everything by -1. And I get x equals 3y minus 9. Now this is my expression for x. So I'm going to take that expression for x and plug it into the other equation for, you guessed it, x. So I have 2, and instead of the x, I'm going to have my expression that I just got, minus 6y equals 12. Distribute. Combine like terms. Positive 6y and a negative 6y will cancel, and I get -18 equals 12. Well, we know that -18 does not equal 12. So our original statement, let me put that back. Put this over here for now. So our original statement of -18 equals 12 is false. If you get a false statement, that means that there's no solution. So think about what we're dealing with here. If we've got no solution, that means we've got no intersection. What types of lines will never have an intersection? Parallel lines. So we're dealing with a pair of parallel lines here, because if there's no solution, that means no intersection. And the reason why we know there's no solution is because we got a false statement. So false statement, no solution, no intersection, parallel lines.